Hello dear viewer or noble subscriber, welcome to the Simplify IT channel where we are simplifying IT problems. Today we are going to simplify the automatic network configuration problem. Let's imagine how many devices surround us now. It might be a tablet, a laptop, a phone or even a server, and how many are currently connected to any kind of network. Setting accurate network parameters for all of them manually has become a very time-consuming task, and today we will explore the technology that solves this problem. The technology was defined in 1993 and is called DHCP, or Dynamic Host Configuration Protocol. And you might ask me, what settings do we need for the client to function properly in a modern network? Well, here they are on the screen. An IP address is similar to a street address of the house. The subnet mask represents the length of the street. The default gateway, it's an exit from our street to go to another street like an interchange or transport hub. The DNS server, it's some kind of directory which helps to translate house numbers into the names of the people or applications located at the same address. Because no one wants to memorize millions of house numbers. We will discuss the technology in the next video. Let's go deeper into the technology. The first phase of obtaining network settings is called DHCP Discover. Let's imagine that we already have a physical network, whether at home or in your organization, whether you connected through the cable or not. Now we are trying to connect a new computer or mobile phone to the Wi-Fi. Naturally, it wants to obtain network settings and broadcast its request to everyone around. Other clients simply ignore such requests, while switch or router, where the DHCP service might also be running, forwards to the appropriate server or servers for processing. In a diagram, it's labeled DHCP server. From the technical standpoint, our client doesn't have an IP address yet, so it employs a placeholder 0000, utilizing either the destination broadcast address 4 times 255. So analogous to a house that is already built but lacks the address, it begins to shout to the entire street, signaling his needs for an address or other network settings. All other houses ignore its cry, not knowing what to do with it. Only the DHCP server doesn't ignore such packet and processes it. Now let's move to the second phase, known as DHCP offer. In this phase, server sends the IP address from the available pool along with other essential network settings. From the technical standpoint, the DHCP server can send a lot of options, but I have highlighted the most crucial ones. And as you see, the response has been sent to the client physical address, also known as MAC address, essentially reaching the GPS location of our house in the street, in practice. The next phase is called DHCP request. During this stage, the client decides which IP address to occupy if it happens to receive multiple offers from different DHCP servers. Prior to acquiring an IP address, the client broadcasts an ARP request to ascertain the presence of another host in the network using the suggested IP. If no response is received, the address is marked available for utilization. In a DHCP request message, the client includes the server identification option, specifying the chosen server whose offer it has accepted. Upon receipt of this message, other servers retract any prior offer extended to the client and return the associated IP address to the available pool. Technically speaking, it's still a shout to the entire street. The last phase is called DHCP ACK or Acknowledge. The DHCP server sends a lease confirmation and the client can use his IP address. Now our client is properly configured from the network perspective. So, job's done! Additionally, I want to share with you some troubleshooting tips. They are in the video description right down below, please check it out. So, that is it. I hope you enjoyed the video and information provided. If so, Please hit the like button and subscribe not to miss the upcoming videos.
Run.